Hello everyone, welcome to another video of Advanced Mathematics of Class 9, and today we are going to start geometric progression, that is GP, and exercise 6.3. So GP, what do you mean by a GP? So just like you saw in AP that the terms in the sequence or the terms in the series have a common difference between them, here we are going to have a common ratio. For example, if I write 2, 4, 8, 16, 32 and so on. In this sequence, if you look at the ratio between two consecutive numbers, suppose second term by first term, that is 4 by 2 is 2. Third term by second term, that is 8 by 4 is also 2. Then 16 by 8 is also 2. 32 by 16 is also 2. That means the ratio of two consecutive integers in this sequence are all equal. So if in a sequence the common ratio is same, then such a sequence is said to be in geometric progression, it is GP. So this is an example of GP. Okay, so we need to have a common ratio, and we denote common ratio by small r. First term will be same, that is a, but the ratio becomes r. Number of terms is also n, and the nth term you can either define it as Tn or you can define it as an, whatever you want according to your wish. So that's how what we mean by a GP. Now what we need to know is, just like in AP we needed to find the nth term, that is Tn or an, and we also needed to find the sum of n terms. So what is the formula in this case? In case of a GP, the formula is a bit different. The nth term, that is Tn. So if the first term is a, common ratio is r, and number of terms is n, in that case Tn, that is the nth term, is a r to the power n minus 1. So a r to the power n minus 1, n minus 1 is the exponent. Okay. So this is the formula for the nth term that we are going to use. Suppose 6th term, 7th term, so T7 will be a r to the power 7 minus 1, that is a r to the power 6. So that's how we are going to find the nth term. Now we need to find the sum up to the n terms, and the formula for this is a r to the power n minus 1 by r minus 1, or it is a 1 minus r to the power n by 1 minus r. Now when should we use r to the power n minus 1 by r minus 1, and when should we use 1 minus r to the power n by 1 minus r? Now that depends on the value of r. This will be used if r is greater than 1, and this will be used if r is less than 1. Okay. So if r is greater than 1, then we are going to use this so that this value comes out to be positive, and here also we are going to use this so that this value and this value, both these values should come out as positive. That is the intention. That's why whenever r is greater than 1, you use r first. Whenever r is less than 1, you use r as the second value here. Okay. So that is how we find the sum up to n terms. Now in any case, if it is not mentioned whether r is greater than 1 or less than 1, suppose it is a variable x. So you have to find that it is given that the common ratio is x. In that case, what you do, you will use r to the power n minus 1 as the formula. If it is not mentioned, or if you don't get the value, until you get the value of r, you will use this formula, not this one. Okay, this is the one you need to follow when the value of r is not given, and you can't also find out directly. So this formula we are going to use. So hope you understood the basic things that we need. Now let's start with the exercise. This is exercise 6.3, and here what do we have? The first question, question number 1, some sequences are given and you have to find the given term. So for example, number 1, question of exercise 6.3, question number 1, and here it is given. Okay, it is A, option A. 1 minus 2 4, 1 minus 2 4, and we have to find the 8th term, that is T8 we have to find. So what do we have here? So it is given that this is a GP, you have to find up to the 8th term and also the sum, we have to find the sum as well. So here the first term is 1, and the common ratio is minus 2 by 1, that is minus 2. So now we need to find the 8th term, that is T8. And for T8, the formula is a r to the power 8 minus 1. So here a is 1, r is minus 2 to the power 8 minus 1, that is 1 into minus 2 to the power 7. So minus 2 to the power 7 is minus 128. that is the 8th term. Now we need to find the sum up to the 8th term, that is S8. Now here the value of R is minus 2. So R is less than 1. That means the formula we have to use is 1 minus R to the power n. So it will be A into 1 minus R to the power n by 1 minus R. So what do we get here? Here A is 1. Now this will be 1 minus minus 2 to the power 8, and this is 1 minus minus 2. Okay, just putting the values here. So it will be 1, so we don't need to write 1, multiplied by 1 is the same number. So it will be 1 minus 256, and here it will be 1 plus 2. So it is minus 255 by 3, that is 85. So it will be minus 85. So the 8th term is minus 128, and the sum up to 8 terms is minus 85. So that's how you solve this type of questions. Now let's move on to another one. Let's try question number D. Let's try D. It is 1, 1 by 2, 1 by 4, that one. So the given sequence is, in question number D, it is 1, half, 1/4, and we have to find up to the 16th term. So 16th term we have to find. So here, what are the values we have? We have A equal to 1 and R equal to half by 1, that is half. Okay. Now R is, again this time it is less than 1. So again we have to use 1 minus R to the power n. So therefore we need to find 16th term. So T16 will be A R to the power 16 minus 1. So A is 1, it is half to the power 15. So it will 1 by 2 to the power 15. This is the value of T16. Now we have to find the sum of up to 16th term. So S16 will be A into, since R is less than 1, so we will use 1 minus R to the power n by 1 minus R. So it is A is 1, 1 minus half to the power 16 by 1 minus half. So 1 minus half is half, and here we have 1 minus 1 by 2 to the power 16. So it is going to be something like 2 to the power 16 minus 1 by 2 to the power 16 by half. So what we get from here is 2 to the power 16 minus 1 by 2 to the power 16 and 2. So these will cancel and we will get 2 to the power 15. So this is the value that we get. So that's how we find the term number, the 16th term, the nth term, and sum up to n terms. That's how we do it. So that is about question number 1. Let's move on to question number 2, and that is a bit different because some of the sequences given here, series given here, are not in GP. So you have to convert them first into GP by doing some manipulations to the given series, and then we can use the required formula to find the sum. So let's look into question number 1, 2a. 2a, it is given that 4 plus 44 plus 444 up to n terms. So this will be up to n terms. So to find the sum up to n terms, so n will remain as n. So to find the answer in terms of n. So now this is not in GP. 444 by 4 is 11, but 444 by 44 is not 11. Okay. So now let's see what to do. We have to convert this into a GP. How do we do this? Let's take 4 common first. What do we get? 1 plus 11 plus 1 1 1 up to n terms. Now this is also not in AP, not in GP. So what we do, the next step we take is 4 by 9. We divide this by 9 and we multiply the whole thing by 9 also. So the 9 cancels out and we get the same thing back. So it is 1 11 1 1 1 up to n terms. So when we multiply it by 9, we get 9 plus 99 plus 999 up to n terms. So let's keep 4 by 9 here. 9 we can write as 10 minus 1, 99 we can write as 100 minus 1, this we can write as 1000 minus 1 up to n terms. So 4 by 9. So now from here let's get all the 10, 100, thousands together, and let's get all the ones together. So we have 10 plus 100 plus 1000 up to n terms. And these are all minus 1, minus 1, minus 1. Let's take minus common. So we will get 1 plus 1 plus 1, 1 plus 1 plus 1 plus up to n terms. Okay. So now what do we get from here? 4 by 9. So look at this. This is in GP. 100 by 10 is 10. 1000 by 100 is 10. So the common ratio is 10. What is the first term? It is 10. The common ratio is 10, means it is greater than 1. So which formula will we use? A r to the power n minus 1. So what is A here? A r to the power n minus 1. N is, we don't know what is n. So 10 into 10 to the power n minus 1. N minus 1. And the denominator will be r minus 1, that is 10 minus 1. This will be, if you keep on adding 1 for n times, suppose you keep on adding 1 for 8 times. So 1 plus 1 plus 1 up to 8 times is 8. So sum up to n terms for 1 will be n. So 1 1 1 up to n terms is simply n. So this is the value that you get, but if you simplify it further, what you can get is this will be 9. So 9 we can take as LCM. This will be 10 into 10 to the power n minus 1 minus 9n. If you want to multiply this further, you can get 9 9s are 81. 4 into 10 is 40 into 10 to the power n minus 1, and 4 into 9 is minus 36n. So you can keep the value here. That is the value you get for sum of this series. So to convert it first into an AP, here GP, here we get the GP, and from here we can go on and find out the remaining ones. So hope you understood this one. Let's move on to another one, and this time let's do a simple one, which is question number D. It is a simple one. It is already given in AP. You have to, GP. I'm sorry, I'm repeating AP over and over again. It is given in GP. You have to find the value of sum up to n terms. So this is a simple one, question number D. It is 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 up to n terms. So here we have, if you look at the common ratio, 1 by 3 by 1 is 1 by 3, 1 by 9 by 1 by 3 is also 1 by 3, 1 by 27 by 1 by 9 is also 1 by 3. So we have a common ratio here. So here the first term A is 1 and the common ratio R is 1 by 3. Now R is less than 1. So we know which formula to use, 1 minus r to the power n. So what do we get here? Therefore sum up to n terms will be equal to A 1 minus r to the power n by 1 minus r. What is A here? A is 1, 1 minus 1 by 3 to the power n by 1 minus 1 by 3. So we don't need to write 1 here. So we will get 1 minus 1 by 3 to the power n, and here we have 3. So it will be 3 minus 1, that is 2 by 3. So if we simplify it further, we will get 3 to the power n minus 1 by 3 to the power n, and it will be 2 by 3. So ultimately what we get is, it will be 3 to the power n and 3 will cancel each other. So what we get, so we can get here something like 2 into 3 to the power n, and at the top we will get 3 into 3 to the power n minus 1. So that's what we can write. We can end it here. Okay, or if you go, okay, you can end it here. Let's keep it here. Let's not make any more complexity, and let's not add any more complexity to this. So that is how you will get the sum up to n terms. So that is how we do question number D. Now let's move on to an even different one, question number G. Now that is a little bit different, because here it is in no type of we have to use a formula. We have to know some formulae in order to get to this, and we have to think differently in case of question number G. So what is given here is a plus 1, a square plus a plus 1, a cube plus a plus 1, and so on up to n terms. Okay, so now let's see how do we do it. Sorry, this is wrong. That's what we have. Okay, so how to do this? Now these are not any formulae, but these are parts of some formulae. Which parts? See, if I write a square minus 1, this can be written as this is a square minus 1, means a square minus 1 square. A square minus 1 square you can write as a plus 1 into a minus 1, right? Or let me shift it like this, it will be easier later on. A minus 1 into a plus 1. That's how we get. Similarly, that means a plus 1 can be written as a square minus 1 by a minus 1. Okay, here. Also, or again, we know that a cube minus 1, that is a cube minus b cube, a cube minus 1 cube. The formula is a minus 1 into a square plus a plus 1. This is the formula. So, from here we can write a square plus a plus 1 is equal to a cube minus 1 by a minus 1. Similarly, a cube plus a square plus a plus 1 can be written as a to the power 4 minus 1 by a minus 1. So, now we have these three, this one and this one. So, in case of these three values we can put these three. So, let us see what we get from there. So, in case of a plus 1 we are going to put a square minus 1 by a minus 1 plus. In case of this we are going to put a cube minus 1 by a minus 1 plus. Here we are going to have a to the power 4 minus 1 by a minus 1 up to n terms. So, here this is also not in GP, but we are going to get the GP. The LCM is same. It is a minus 1. So, here we have a square minus 1, a cube minus 1, a to the power 4 minus 1 up to n terms. Denominator remains the same. Here now we can arrange all the a's together and all the 1's together. So, we have a square plus a cube plus a to the power 4 up to n minus 1 plus 1 plus 1 up to n terms. So, see, this is now in GP because the common ratio a cube minus s by a square is a to the power 4 by a cube is also a. So, the common ratio is a, first term is a square. Now, as we do not know whether a is greater than or less than 1, so the formula that we are going to use is a into r to the power n minus 1. As I mentioned previously, if you do not know, then use the first formula. So, the first term here is a square into r to the power n. So, it is common ratio, our common ratio is a. So, a to the power n minus 1 a to the power n by a minus 1. This is going to be the sum of this, and if you keep on adding 1 for n times, you are going to get n. So, it is a minus 1. So, ultimately what we are going to get, a minus 1 will be the LCM. So, you have a square into a to the power n minus 1 minus n into a minus 1 by a minus 1. So, it is a minus 1 whole square. Here you get it a square a to the power n minus 1 minus n into a minus 1. So, that is what you get for question number G, the sum up to n terms. Again, it was not given in AP, we had to convert it using a different method. We had to identify that these are parts of some formulae, and using those formulae we found out the sequence, sum of the series. So, that is how we do it. Now, let us move on to another one, question number J, that is also different. So, let us see how to do question number J. In J it is given 1 into 3 plus 2 into 5, 1 into 3 plus 2 into 5 plus 3 into 7 plus dot dot dot. These are not 1.3, 2.5 and 3.7, these are multiplications. Did dot dot means multiplication. So, here it is a bit different. Let us find the nth term. We have up to n terms. So, to find the sum up to the nth term, right. So, let us find the nth term. So, here what will be the nth term? Let us find the general term. You remember how we found the general term in our second exercise 6.2. In the same way, let us find general term here. So, if you look at the two factors here, 1 into 3. So, the first factor of each number, it is 1, 2, 3, next one will be 4 into something, then 5 into something, 6 into something. That means, this one is 1 for the first term, 2 for the second term, 3 for the third term, it will be n for the nth term. So, this is n. Here the second factor is 3, 5, 7 odd numbers, but starting with 3. So, any series or sequence that starts with 3 and keeps on getting the consecutive odd numbers, the general term is twice n plus 1. So, n into twice n plus 1. If you remember how to find general formula, you will get this. So, This is the nth term. So if we have to find the sum up to the nth term, how do we do it? Therefore, summation of Tn, we need to find the sum in summation of Tn, and value of n goes from 1 to n. This will be equal to what? Summation of Tn means you have to keep on adding 10 how many times? For the value of n should be 1 to n. It starts from 1 lower limit and it goes up to n, that is the upper limit. So how do we do this? That means we need to put the value of n twice n plus 1 from 1 to n. So summation of Tn will be summation of n into twice n plus 1 from n equal to 1 to n. So let's keep summation n equal to 1 to n. If you break the bracket, you will get twice n square plus n. Okay. So now let's split it out. By splitting, we will get twice n square plus summation of n. So 2 is constant, so let's get 2 out of the equation here. It is n square plus into n. Now summation of n square means you have from 1 to n, that means you have to keep on adding 1 square plus 2 square plus 3 square plus 4 square, that is sum of the squares of all natural numbers. Sum of the squares of all natural numbers has a particular formula, and that formula is n into n plus 1 into twice n plus 1 by 6. This is the formula for sum of the squares of natural numbers. Similarly, the formula for the sum of natural numbers means 1 plus 2 plus 3 plus 4 plus 5 up to n is n into n plus 1 by 2. Okay, so this is the formula for summation of n square up to n, and this is the formula for summation of n, where n is the sum of all natural numbers. Now let's continue this one. This will be 2 cancel 3. So what we get here is n into n plus 1 into twice n plus 1 by 3 plus n into n plus 1 by 2. Let's take an LCM of 6. So it will be twice n plus 1 twice n plus 1 plus thrice n into n plus 1. Again we can take common here, we get n and n plus 1 as common. So let's take n into n plus 1 common. What we get here, we are left with 2 and this. So it will be 4n plus 2 plus 3, 6. So it will be n into n plus 1 into 4n plus 5 by 6. That is the value of j. So that's how you find. So we have done 4 sums. Each of the 4 sums were different. So you could understand that there are different types in which we can find or solve the summation of or find the sum up to n terms for any given series. So even if it is not in either AP or GP, you have to convert it into an AP or GP, and then we can find the sum. So hope you understood what we explained here today. So if you have any questions, make sure to ask me in the comment section. So thank you everyone for watching, and until next time, cheers.